Hello everyone, HMT here, and today we're going to derive both the cosine law and the sine law. This is a statement of the cosine law, and we will use this triangle, as it's labeled, to help us derive this cosine law. Find out where this formula came from. To do that, we'll drop a perpendicular from B to the other side, AC. And I'll label that H for its length. It meets a side AC at a 90-degree angle, so I'll put a perpendicular symbol in there. Now suppose this distance from here to here happens to be x, and the full distance across the bottom of the triangle is b. This distance here would be b minus x. I'm going to make a note of something before we begin the heavy calculations, and that is inside this triangle, the cosine of angle A is adjacent over hypotenuse. So we'll make a note of that. We're going to say the cosine of angle A is adjacent side divided by hypotenuse multiplied by c on both sides, and we get c times cos of A is equal to x. And now we begin the heavy lifting. We're going to apply the Pythagorean theorem twice, once in this right angle triangle and once in this right angle triangle from the viewpoint of h. That is, I'm going to write down that h squared is equal to this hypotenuse squared minus this leg squared. So that squared minus that squared is going to give us h squared. So I've got a squared minus b minus x quantity squared. But wait, on this right angled triangle, h squared is c squared minus x squared. So I could continue the calculation and say that's c squared minus x squared. If we simplify this equation, the cosine law will result. All we need to do is carefully simplify this equation and we'll be fine. So I'm going to multiply this by itself. I'm going to square that out. So that gives us a squared minus b minus x times itself equals c squared minus x squared. There's not much I can do with the right side at the moment, so I'll just leave it here on the right side and I'm going to multiply this out. So that gives us a squared minus b squared minus 2bx plus x squared equals c squared minus x squared. Then I run the minus sign through these brackets, and that would give us this. A squared minus b squared plus 2bx minus x squared equals c squared minus x squared. I will now get rid of these terms by adding x squared to each side. So I've got a plus x squared on the left side and a plus x squared on the right side. The next line will be much simpler. That will be a squared minus b squared plus 2bx equals c squared. Next job is to take these two terms here and move them to the right side. That gives us a squared equals b squared plus c squared minus 2bx. But wait, x was equal to, remember, c times cos A. I'm going to substitute that in now. So the x value is going to become c cos A. So that gives us a squared equals b squared plus c squared minus 2b times c cos A. And that's the cosine law, derived from scratch. Let's derive the sine law now. The sine law can come in two variations, with sine of angles on top or sine of angles on the bottom, depending on how you want to use the sine law. So you can use either version, it's fine. Okay, to derive the sine law, what we'll do is drop a perpendicular from the top vertex down to the base. So that will come down here, and that will be called h. And now I'm going to make this is 90 degrees, and I'm going to use the sine ratio inside each right triangle. I'm going to say that the sine of angle B is opposite over hypotenuse. Then I'm going to go over here to this right triangle, and I'm going to say the sine of angle C is the opposite side over the hypotenuse. Both equations will contain h, and that's the link that joins them. That's what's going to help us out here. So I'm going to say the sine of b is opposite over hypotenuse. Meanwhile, over here, I've got the sine of c is opposite over hypotenuse. In this equation, I multiply both sides by c to clear out any fractions and isolate h. And that's going to give us c times the sine of b equals h. Over here, I'll do the same thing. I'll multiply both sides by b. The b's cancel, and I get b times sine c equals h. But the h here is the same as the h here. Therefore, these expressions must be equal. I will set them equal. See what follows after that. So therefore, c times the sine of b equals b times the sine of c. From here, I'm going to divide both sides by bc. Follow the cancellation. Now the c's cancel, giving you sine b over b. And here the b's cancel, giving you sine c over c. Now, where did sine a over a go? That's part of the sine law, and we only got part of it, it looks like. Did something go wrong? There's supposed to be two equal signs and three expressions, but we only got two of them. Well, this is one of these proofs that's done piecemeal. If I had done this and dropped my perpendicular this way at the start of the proof, then I would have got a relationship between a and c. I would have got the following relationship if I happened to have dropped my perpendicular this way. I would have gotten the following. Sine a over a equals sine c over c. That's what would have happened if I happened to drop my perpendicular this way. But wait, we already have a sine c over here, and that's known to be equal to sine a over a. And so I can actually include this now. It's the same thing. Sine a over a. Now you could take reciprocals here, right? You could just flip this in the sense that 1 over 2 equals 2 over 4. You can flip it and take reciprocals in the sense that 2 over 1 equals 4 over 2. So I can take reciprocals here and get a over sine a equals b over sine b equals c over sine c, depending on how you choose to use the sine law. Thank you very much. If you enjoyed this video, please like, subscribe, and share. If you have any suggestions you'd like to see for future videos, please leave them in the comment section below. Thank you very much.